Okay, question 2. When consumers apply for credit, their credit is rated using the FICO score, Fair Isaac Company. A random sample of credit ratings is obtained, and the FICO scores are summarized with these statistics. Sample size is 18, sample mean is 660.3, sample standard deviation is 95.9. Use a 0.05 level of significance to test the claim that these credit ratings are from a population with a mean that is not equal to 700. Step 1. State the null and alternative hypotheses. We are dealing with the parameter mu because of all of the talk about the mean. So mu, the researcher comes along and he says that he thinks that these scores are from a population that has a mean other than 700 or not equal to 700, points us to a two-tail test. And then we know that the null is always structured as mu is equal to. Step 2 is just state alpha. Alpha is 0.05. Step 3, compute the test statistic. X bar minus mu 0, s over the square root of n. X bar is given. 660.3. Mu 0 is the standard. S and n. 18. Plug in. Divided by the square root of the sample size. And we get minus 1.76. Step 4. We have to choose either the p-value or classical, and in this case, step 4, we will use the classical. This is a two-tailed test. So we've got two values here. We need to find the critical values, T alpha divided by 2 and minus T alpha divided by 2, where this region is the critical region and this region is the critical or rejection region. Critical region here and critical region here. To find minus T alpha by 2 and positive T alpha by 2, we're going to use the inverse T with alpha divided by 2 and degrees of freedom. Remember, alpha over 2 we have to use when we're dealing with a two-tailed test. So alpha is 0.05 over 2. Degrees of freedom is 17. So let's go over here and see what we get for the critical value. Inverse T, alpha by 2, comma, degrees of freedom, and we get 2.11. So this one is minus 2.11, and then we've got the positive 2.11. And then step 5 says compare the test statistic, which is minus 1.76, to the critical values. And that, remember, the easy way, we talked about this in class, the easy way to do this is to determine if T0 is in the red region. And we can clearly see here that T0 is not in the red region. T0 is somewhere right in here. This is minus 1.76. So the conclusion here, step 6, is to fail to reject HO. Fail to reject HO. So again, we're saying that there is not enough evidence. The conclusion is that the results are not statistically significant. Therefore, we conclude there's not sufficient evidence to support the researcher's hypothesis. Next question. In 1990, 5.8% of job applicants who were tested for drugs failed the test. So around 6% of the people who were drug tested actually failed. At the 0.01 significance level, test the claim that the failure rate is now lower if a simple random sample of 1,520 current job applicants results in 58 failures. Step 1 is to structure the null and alternative hypotheses. So again, the key here, dealing with a percentage, we want to go with the population proportion P, and we're testing the claim that the failure rate is now lower. So that's kind of a key word to describe a left tail test. Lower than what? Lower than what it was in 1990, which was 5.8%, and then of course the null is here. Step 2, state alpha 0.01. Step 3, compute the test statistic, which is p hat minus p0 divided by the square root of p0, 1 minus p0 over the sample size. So we have to get p hat. P hat is x over the sample size. So 58 over 1520. And that gives us 0.038. And of course P0 is our standard 0.058. That's the 5.8%, and our sample size is 1520. So let's plug in. One minus and we get minus 3.34. Step 4, and remember, this is where we deviate. We want to stick with the p-value approach on this question. So we're going to write down our image from our tables for a left tail test. Z0. And this is the p-value, the red area. So the question is, what is P0? Well, Z0 is what we just calculated in step 3, minus 3.34. So the p-value is equal to the probability that Z is less than minus 3.34. And we just looked this up in table 5. So minus 3.34 is 0.0004. That's our p-value. And now, step 5. If p-value is less than alpha, reject. HO. So the p-value is equal to 0.0004 and alpha is 0.01. So this information here, since the p-value is less than alpha, we reject H0. Okay, so step number 6 is to state the conclusion. So if we reject HO, then we're saying essentially that we're rejecting this statement. So we say that the percentage of job applicants who were tested for drugs and failed the test is now less than 5.8%, and the results are statistically significant, and that's what we say. We state the researcher's hypothesis. Okay, question 5. Randomly selected statistics students of a professor participated in an experiment to test their ability to determine when 1 minute or 60 seconds has passed. So essentially what happens here is you take the first student and you ask them to determine when 60 seconds or 1 minute has passed by. And essentially probably what they're going to do is they're probably just going to count in their head like 1, 1,000, 2, 1,000, 3, 1, so on and so forth. Then you move on to student 2 and you ask that student to tell you when 1 minute has passed. And so you kind of start the stopwatch, and then you stop it when they say 1 minute has passed, and you record the times. Okay, so this hypothesis testing question is dealing with the parameter mu, and so step 1, we're going to structure the researcher's hypothesis. And so let's read through here. 40 students yielded a sample mean of 61.7 seconds. So the sample mean, X bar, comes from these 40 individuals, and that mean time is 61.7 seconds. Assuming that the sample standard deviation is 9.5 seconds, use the 0.05 significance level to test the claim that the population mean is greater than 60. So the population mean is greater than 60. The population mean is equal to 60. All right, so step 2, alpha equals 0.05. Step 3, compute the test statistic. So we know by now that that's T0 and not Z0. X bar minus mu 0, S over the square root of n. So X bar is 61.7. And the mean, the standard, the population mean, what we think it should be, or what we hope it is 60. And the standard deviation, of our sample is 9.5, and our sample size is 40, the 40 selected students. So let's see what we get here. So we get minus, or positive, rather, positive 1.13. Okay, step 4. We have to choose either a p-value or a classical approach. And I think we're going to stick with the p-value here. So let's write down our image, which is a bell curve. And this is a right tail test, so we're going to look at T0, and this is the p-value right here. So the formula is for the p-value, the probability that t is greater than t0, where t0 comes from this step. So t0 is 1.13, and remember here we're going to use the TCDF, so t is greater than 1.13, and again lower bound, upper bound, degrees of freedom. So the lower bound is here because this is where we're starting. The upper bound is way out there in positive infinity somewhere, so we'll just use a really big number, TCDF. Lower bound is 1.13, upper bound is 1 times 10 to the 99, that's our really big number. Degrees of freedom is sample size less 1, so 40 minus 1 is 39. So let's see what we get for the p-value here. So we're going to go distribution, TCDF, lower bound is 1.13, upper bound is 1 times 10 to the 99, comma, degrees of freedom is 39, close, and p-value 1327. So the p-value is 0.1327. Okay. Step 5. Compare the p-value to alpha. P-value and alpha. Alpha is 0.05. And if the p-value, if this number right here is less than this number, then we reject. Well, of course it's not less than 0.05, so we fail to reject. And so let's go back up here, and we fail to reject means that we do not have sufficient evidence to support the researcher's statement. So there is not sufficient evidence to support that the mean is greater than 60. Okay, we'll move on to question number 6. Let's see, when 14 different second-year medical students at Bellevue Hospital measured the systolic blood pressure of the same person, they obtained a mean of 133.92. So essentially what you have over here is you've got this guy, and then you've got the first second-year medical student, the second-year medical student, all the way down to the 14th second-year medical student. And they each took this guy's blood pressure reading, okay? And they came up with an average of 132.9 for the average blood pressure, and a standard deviation to be 10. The patient thought he had a blood pressure that was close to the mean for his age, which is approximately 140. Use a 0.05 significance level to test the claim that the mean blood pressure level is less than 140 milligrams or millimeters of mercury. So step 1 is to state the null and alternative hypotheses. Again, we're dealing with the mean and not the proportion. So test the claim that the mean blood pressure level is less than 140. So this is going to be a left tail test. Step 2, alpha 0.05. Step 3, the test statistic. So X bar is the 133.92. The standard for his age is 140. Standard deviation is 10 divided by the square root of the sample size, which is the 14 different second-year medical students at Bellevue Hospital. Okay, so we get the test statistic is minus 2.27, again, which means that this measurement here is exactly 2.27 standard deviations below what it should be. And again, we know that the more standard deviations that the actual statistic is away from the parameter is stronger evidence in support of the researcher's hypothesis. So step 4, we're going to use the classical approach, which means we have to write our bell curve. And we're going to have the critical value, and we're going to use the inverse t with alpha and degrees of freedom to help us find the critical value that separates the critical region . So we get inverse t, alpha 0.05, degrees of freedom, sample size less 1, so 13. And so let's see what we get here for the critical value. inverse T, .05 for alpha, comma, degrees of freedom, 13, enter. So we get minus 1.77. And then step 5, we compare. If T0 is less than minus T alpha, reject HO. So let's do a quick comparison here. So T0 we got to be minus 2.27, T alpha minus T alpha minus 1.77, and so clearly we can see that T0 is definitely less than minus T alpha, and also it's in the red region too, so this information tells us to reject HO. Reject HO. So let's go back up. We reject HO. If we reject HO, we say that the results are statistically significant, and we have enough sufficient evidence to conclude that the mean blood pressure for this patient is less than the normal value of 140.